Hello everyone and welcome to my video blog. Today I will be taking you on a tour to Lynn Creek in North Vancouver. Lynn Creek is situated in North Vancouver and originates in the protected Lynn Headwaters Regional Park. It then flows south in a meandering pattern, as we can see here, and discharges its waters into the Burrard Inlet, which is part of the Pacific Ocean. Lynn Creek extends 18 kilometers in length and is bordered by Seymour River on the west side, which is here. According to the Köppen-Geiger climate classification system, North Vancouver climate is classified as a CFB climate, shown in green here, which is a marine west coast climate. This means that it experiences mild summers and winters and an abundant annual precipitation. North Vancouver has a marine west coast climate because of its proximity to the coast and to the mountains. Wet, warm air from the coast rises and cools as it travels over North Vancouver mountains. This causes the water vapor in the air to reach saturation and condensation, resulting in high precipitation, which is known as the rain shadow effect. North Vancouver experiences its lowest temperatures in the season of winter, specifically in the months of January and December, and experiences its highest temperature values in the summer in the months of July, June, and August. If we look at the precipitation values here, North Vancouver experiences its highest precipitation inputs during the winter season, specifically in the months of October, November, December, January, and February. And then it starts decreasing as we enter the spring and summer. The high annual precipitation means that the stream discharge of Lynn Creek will increase as it flows down into the Burrard Inlet. North Vancouver is 96 meters above sea level. In this topographic map, we can see the high mountains of Lynn Headwaters Regional Park, where Lynn Creek originates. At this elevation, the topographic gradient or slope is steep, which increases the velocity of Lynn Creek water as it travels south, creating the meandering feature of the creek that we can see here. As the water flows south, the elevation decreases as well as the topographic gradient, slowing the water down as it discharges into the Burrard Inlet. The first feature that we're going to talk about today is the meandering of the river. The high energy, fast moving water that is coming from the steep slopes of Lynn Creek headwaters hits the cut bank of the creek and erodes the sediment underneath. We can see here that the sediment is mostly composed of large rocks that increases the friction and slows down the water. As the water slows down, it cannot carry the large sediments into the other side of the creek and deposits them there, forming the point bar. Shown on the right side of the screen is the second feature, which is the point bar. And as mentioned, the point bar is a depositional feature that accumulates on the inside bend of the creek below the slope. We can also see here the low-lying area on the side of the creek, which is the floodplain. During winter, and specifically high precipitation seasons, the creek overflows its banks and deposits sediment on the floodplain. We can also see here the process of abrasion on rocks, where the high energy water is rushing over the rocks, making them smoother. This hydrograph shows the annual stream discharge rate of Lynn Creek. As we can see here, Lynn Creek experiences high stream discharge rates in the months of December until June because of the high precipitation input into the creek in the winter season. In conclusion, we can see how the topographic gradient and the stream discharge affected the different features of fluvial systems. This project helped me understand the different features of rivers and creeks, and I really enjoyed going to Lynn Creek and observing the features in it.